Welcome to the lab report. This is a basic overview of the shoulds and shouldn'ts of writing a physics lab report. So why do we write lab reports? A lab report is simply a specific type of argument or persuasive document. It should lead your reader through your data and analysis so they reach the same conclusions that you reached. To do this, you need to present your information in a logical and readable manner. Here are some general tips. Be professional. Write as if scientists from around the world might read this report. Be honest. Recognize I will be looking for neatness, correctness, and conciseness. Don't fill your paper with just fluffy words. I don't grade by the inch. I'm actually looking for you to make your argument and support it with meaningful data. Contents of your lab report. Each lab report should include the following information. There will be 4 distinct sections. First is your introduction. In your introduction will be your title, which has your name, your period, the class, and what you're calling this particular document. The purpose, the variables, being independent and dependent, your hypothesis, and of course, what procedure you used. What did you do to complete this? The next section is your data and observations. These are your results. What happened when you did your lab? Oftentimes they will be given in a table or a graph format. Then will come your analysis. This is where you're explaining what does your data mean. This is where you will include any calculations that you do with your data in order to reach further information. Make sure that it also includes any uncertainty and experimental error and an explanation of it. And finally, last of all, is your conclusion. Let's take a closer look at each of these sections. First, in your introduction, you are really explaining to your audience what you're doing and why you are doing it, and a detailed look at what you did. For the what you're doing and why you're doing it, that is what our purpose statement is for. This is a statement of the problem, and it provides the overall direction for the laboratory. Honestly, a purpose statement should not be more than 2, maybe 3 sentences at the most. Keep it clear and concise. Let's take a look at examples. Okay, these are both lousy examples. Notice in neither of these do I have a clear idea of what is being done or why it's being done. Let's look at some better ones. These are about the same lab, and notice they really aren't very long, 2 sentences at the very most. But in each of them, we know what was done, why it was done, and what changes we were using as our variables. Now, when we're talking about variables, we're talking about independent variables. That is what you will be changing. And your dependent variables. What effect will it have? For example, if you take measurements at certain times, that's your independent variable, you expect to see temperature changes. That's your dependent variables. Another example, use pennies with different minting dates, independent variable, to see changes in the mass, dependent variable, because the change in the mass depends upon the date in which it was minted. Is that clear? All right. Then you're going to give your hypothesis. What do you think will be the effect of changing that particular variable? So as your independent variable, describe how you will change it. What do you expect the dependent variable will do? For example, as heat is added to the water over time, temperature increases. Next, we're getting into the nitty-gritties of the lab itself. What materials did you use for this investigation? I am looking for a detailed labeled diagram and list, not one like this. Notice how unclear this is. If I went to try and gather the materials to do this lab, I would be very lost. As opposed to this one, where I have a clear labeled list and then a picture. A picture's worth 1,000 words at this point in time. So the next part is your procedure. How did you do it? This is step by step. I want you to describe what you will do and how you will do it. This always needs to tie to the purpose. And it should be so specific that, heck, your little sister could actually follow it by just reading your report without knowing anything about it. So here's a bad example. Notice there's nothing specific about it. I don't know what masses were used. I don't know what weights were used. I don't know what they did. In truth, this is very confusing. Here's an example related to creating a peanut butter and jelly sandwich. Hopefully, if I did this right, anybody who wanted to could make a peanut butter and jelly sandwich just by following these instructions. That is how clear your procedure should be. Whew. Seems like an awful lot of work just to get your introduction done. And it is true that it is, because this is where you lay the background so that your audience can understand your data and results. So now, your section on data and observations. This is what happened. All your graphs and data should be clearly labeled and titled so that I know exactly what I'm looking at, and so does anyone else who's reading it. Here is a bad example. Notice there are no units. I don't know what each of these columns actually means. There's nothing for me to tie this to. It's just a random bunch of letters and numbers. As opposed to this one, where it's labeled, where things are identified, and each column has units, so I know what we're looking at. Now, the next section you're going to be doing is your analysis. What does all of that data mean, and how does it relate to your stated purpose? This section really should include finished calculations and answers to lab questions. Be sure to use complete sentences, and in general, make the answers as clear and readable as possible. Assume that your reader does not know what analysis questions are posed in your lab handouts. Include enough of the questions in your analysis so that your reader knows what you are discussing without having to read the questions. Make sure that you include all graphs, make sure that you identify any trends, and make sure that you clearly state the meaning of any graphs that you put into this section. Now here's a bad example. If you read through this thing, and this was one that was actually taken from a real lab report, the students simply use up half of this restating laws, even though it doesn't have very much to do with what they're writing about. Here is a better example. Notice how with this one, you are taking a look at what calculations were made in order to figure out the acceleration. Then they graphed that information and described what each of those graphs meant. Then they looked at and explained the graphs and identified trends to further analyze their data. Oh, almost done. Now your conclusion. Your conclusion is not just a copy and paste of your analysis. This is where you actually tie it in to basic principles of physics. This is where you tie it back to your introduction and your purpose and your hypothesis. This is where you get a chance to explain why it was different from what you expected. This is also where you can make any personal observations, suggestions, future plans, etc. Here's a bad one. Notice that this person did none of the above. But boy, look at the brownie points they're trying to give me by telling me that it helped them to become a better student in person. Now that's just silly. Try and keep it professional. Here is the start of a conclusion. Notice in this one, it talks about how their data supported their hypothesis. It uses the graph to back up that statement. And then it ties it back to some basic physics principles with the concept of specific heat. Now this isn't finished, but it's a good start. Okay, final word. Be clear, be accurate, identify your variables. I don't grade by the inch, my focus is on the content. Let the picture tell your story when you can, just make sure it's relevant. And that's it. 4 sections. I know a lot of words, but as you start building your lab reports, you're going to find that it helps to clarify your thinking and make sense of what we're doing. Hang in there, folks. We'll see you tomorrow.